The increasing development of language learning models, LLMs, has drastically increased since the birth of modern LLMs in 2017. These models have evolved from just being answer engines to search and query information into conversational agents which can shape opinions and thoughts. The evolution of LLMs into conversational agents has granted the opportunity for opinionated query searches. The changeover has limitations, which models asking their own decision-made questions instead of prompting specific knowledge only derived from the allocated search sources. The queried search outputs of the AI are opinionated, which provides a gate into lost transfer of crucial data missing in responses. Due to the difference in thinking between AI and humans, responses prompt untrustworthy and unreliable outputs, and users of these LLMs need to factually check information for every response. In the Harvard Business Review HBR article, research discussed that over a comparison of 1,600 human executives with 13 leading language models, found that AI systems, specifically query-based inquiries, use markedly different question mixes than the counterpart human leaders. Often, the LLMs tend to overemphasize interpretive analysis while undermining the productive and subjective questioning. Over a test of 13 models, each model was tested 200 times. 10 out of 13 LLMs allocated points to interpretive questions rather than productive and subjective reasoning. This leads to asking questions such as, what did we learn? And were our goals met? Instead of focusing on productive research involving synthesis of actual information to make sure fact-checking has occurred. Due to the vast variety of questions being asked the LLMs, each question surfaces information which often leads to imbalances. The HBR articles stating that these LLMs cause blind spots, skewed discussions, and subtly steer outcomes. As stated before, due to these imbalances, users of these LLMs always need to second-guess their synthesized information, check information factually, and can cause questioning if the response is viable to use.
Strengthening the way knowledge is conveyed and created within large language models are essential to address the challenges and risks associated with the rapid development and use of artificial intelligence. A key improvement that can be made to the expanding use of AI is to implement stronger knowledge representation strategies when designing and using LLM systems. This improvement can be made from changing how knowledge is sourced and structured within AI models. Commonly, AI models are designed to follow fairly free-formed inquiry paths, which can be useful to employ a conversational tone with an end user, but can create issues with the accuracy of information being provided. To combat this, AI systems can be designed to follow guided, structured knowledge frameworks during the internal thinking process. These frameworks can direct models to systematically collect data and explore different research paths, which include balanced question types, ranging from interpretive, productive, and subjective questions, which offers a more comprehensive reasoning process, leading to a greater data spread being consulted. As a result, this process will generate a more nuanced response from an AI model, which reduces the risk of evidence-based insights being overlooked. Moreover, human fact-checking and oversight of artificial intelligence usage is important in filling critical thinking gaps most LLM systems are not capable of. As AI models tend to ask fewer productive questions that prompt further questions than humans, embedding human review checkpoints within an organization when using AI can aid in refining and enhancing the quality of AI-generated outputs to maintain the reliability of this AI-aided content. This supports the authenticity of using AI-generated responses by verifying the AI's output, which can support an accurate transfer of knowledge between AI systems and the human decision-makers within the organization. This is particularly important within higher-stakes professional settings that require precise information. Additionally, transparency within sourcing knowledge from LLM systems is essential. Users of these systems should be able to view and understand how the artificial intelligence arrived at a conclusion, making it clear what data points may have been prioritized or excluded. This can occur when AI models illustrate the reasoning path taken to generate a response, which can help highlight uncertainties found in its line of questioning. This allows users to evaluate the accuracy of the AI output more easily, prompting users to not blindly trust AI models when the inquiry path is easily accessible to them. Through this process, transparency can be created between AI processes and humans, which in turn can lead to more insightful responses from AI. Humans can continuously question the output and focus on areas that may have initially been ignored or were incorrect.
In conclusion, while AI has become a powerful tool in shaping decisions and generating knowledge, it also introduces significant risks when used without critical oversight. As discussed, AI systems tend to prioritize interpretive questioning, which can lead to blind spots, biased outcomes, and reduced reliability of information. Therefore, it is important that users do not solely rely on AI, but instead actively question, verify, and evaluate the responses provided. Ultimately, the most effective use of AI comes from combining its efficiency with human judgment, ensuring more accurate, balanced, and trustworthy outcomes.